So as a data engineer, what we are going to do? So we will be building these pipelines to read the data from source systems. So whatever a source system can be anything, whether it can be a SQL server or a front end application or AI application, or maybe somewhere in the if you consider hospitals, they will be using some standalone applications, right? So in the healthcare domain, so they that applications, they can also be our data sources, so we can read data from anywhere. So we need to build a pipeline. If we want to build a data lake or data warehouse in cloud services or somewhere, we need a source and we need a target. A source can be anything. So here we will be having two kinds of data pipelines. One is the generic pipeline, like end application, as we discussed, like healthcare domain. In healthcare domain, like in hospitals, we'll be having some application types. So everyday patients will be coming, and there will be new patients or revisiting patients. They will be entering some data. So that data we need to store in data lake or data warehouse. So the first pipeline is building from end application to storage system, and the second one is migration, which we are seeing in real time scenarios. The second system is mostly we are seeing in recent time projects. Like there will be a XYZ company which established 20 years ago, which with a traditional SQL Server database, and now they wanted to migrate to cloud services, right? Their architecture or data model, whatever it is, their entire system was built on-premise SQL Server. Now they wanted to migrate to AWS cloud system. What we need to do is we need to replicate their entire system in cloud service, along with loading the existing data from on-prem. Like they were established 20 years ago, right? They will be having 20 years of data. We need to migrate that data from SQL Server to cloud service. That's one-time pipeline. Like once the entire data is loaded, the new system will be taking over from there. So the data integration. Data integration is again whatever we discussed in the previously. It's like getting the data from multiple sources and integrating it at one point. I mean, merging it at one point. Infrastructure management. Infrastructure management is like what are all the services we are doing, access control, and integration of these services. Like let's say if we are working in AWS for processing, if we are using Glue, and data warehouse we are using Redshift, integrating Glue and Redshift, and some other services like let's say if we are using SNS for notification, it's like AWS SNS, which is simple notification service. So if we are using SNS, integrating that SNS with Glue and warehousing, and if we are using some other services like AWS S3 and Lambda, integrating all these services, like the maintaining the infrastructure of all these services. That as a data engineers, we are going to do that. Again, we are doing data modeling, data quality checks, and database designing, and as usually job optimization. We need to get the best of the jobs we do, right? So we need to run as fast as possible and as efficient as possible. So we need to do that, and security implementation is nothing but access control to the services and data. So all these things as a data engineer, we will be doing. So we have other roles like data scientist and data analyst. As we all know, data scientists will mostly deal with machine learning, data analysis, modeling, and visualization. And data analysts will also do the similar things like data engineer. So whatever data analyst will do, a data engineer can also do those things. Like additionally, the primary thing for data engineer is building the pipeline and maintaining the infrastructure, processing transformation. But for analyst, it will be like whatever the data we process, they will be cleaning that, analyzing, querying, generating reports in Power BI or QuickSight or Tableau side anywhere. And it's like whatever data engineer build, that data will be used by analysts to do this reporting as an end user or the intermediate user to report it to clients or customers. So we have other roles also, like it varies from organization to organization. Some organizations, engineers act as data analyst and as well as database administrator. I mean, they will take the entire part. But you go into a wider organization, the roles will be different. One will be doing the data architect, one will be managing the database, one will be maintaining the infrastructure, one will be acting as data analyst, and there will be one more person where he will be doing only data quality checks for the reports and the processing data. So this varies. So, but as a data engineer, we need to aware what kind of things we can do with data. So till now we have discussed about what is big data, and as a data engineer what we are going to do, and how we can handle big data on a high level note. So far, anyone have any questions or any doubts?
All good, Shrikant. Thank you.
Okay. So we discussed about Spark framework, right? So which will be used to process data. So for running Spark jobs, we need to create a cluster. So I think everyone is aware of what is a server and what is a cluster, right? So the Spark applications will be run on cluster. So let's say if I created a cluster of 100 GBs memory, and currently all my Spark jobs are running fine. Whatever the jobs I am triggering, Python jobs, Spark jobs, so all the jobs are running the 100 GB memory or cluster. It is sufficient. But after 6 months, my data got increased, and I'm unable to process my jobs in that cluster. So what I can do? I need to increase the cluster size. The data is doubled every 3 months. I need to do the maintenance of the cluster for every 3 months, like increase the cluster resources, and I need to integrate. So increment. So at one point, the cluster, the server won't be able to manage the cluster, single cluster. So I need to expand my server itself. So if the data is increasing exponentially, I need to increase cluster, and after some point, I need to expand my server as well. So that will be going to very much cost. So to avoid that, we have cloud services coming to picture. So they will be maintaining where these cloud service providers like AWS or Azure or GCP. GCP is nothing but Google Cloud. So all these cloud service providers, what they will do is they will maintain huge servers somewhere, and they will provide us these services, whatever the services they are having in their server, they will be providing us for the cost we are paying. Let's consider a server and a cluster for a Spark application. So as we discussed, my Spark applications are running, all my Spark applications are running fine for 3 months. And after 3 months, data got doubled, and I need to expand my cluster. And after 1 year, even the entire server is not sufficient my Spark job, and I need to expand my server. So that will be costly as we discussed. But coming to AWS, let's consider AWS. We have EMR. What EMR is? It's like a cluster. I can create any number of clusters in EMR servers. I mean AWS server. So what I can do is I will have a provision that I can create EMR cluster of my own size. Let's say take the previous example of 100 GB memory configuration. So I can create my EMR. If I'm not, my Spark jobs are not running on that EMR, I mean, more memory, more compute power is needed. I can expand, I can create one more cluster with more memory, like let's say 200 GB. And even if that is not sufficient, I can increase cluster configuration. Let's say I think the previous example is sufficient. In the previous example, we are also talking about server expansion. But in AWS, we don't need to take care of the server. All we need to do is we just need to create a cluster of the configuration we needed and throw our Spark jobs at it. So then it will run fine. There won't be any point where we need to expand AWS server. So basically AWS Amazon will be having the huge servers. Like let's say there will be different regions, they will be maintaining servers at different regions. Their servers will be very huge. So we cannot estimate how bigger their servers are. We can make utilize of available servers to create our clusters and run the job. So whenever I think I need more resources, I have the flexibility to increase the configurations. So the cost. So in traditional way, we are having your own server. You need to pay for that entire server. But in cloud services, you don't need to pay for the entire server. You need to pay whatever you are utilizing from that server. So which will reduce the cost very much. Paying for a server is very huge, but paying for a cluster or whatever the part of server we are using, that will be very much less. And managed services, AWS will be having AWS or Azure or GCP will be having multiple services provided. Let's say to run basic Python jobs, small jobs, we have Lambda. To run these Spark applications, we have AWS Glue and EMR. Per and To send notifications, we have SNS. And there are other services which will be managed by AWS. We don't need to manage anything in AWS. All we need to do is go to the service we need, pay for it, use it, and you pay for what you use. You don't need to pay any extra. And storage options, like we have multiple storage options, like for warehousing we have Redshift. We can store data in S3 file system. We'll be having multiple systems. We can integrate other services like Snowflake to AWS and all. Global reach in the sense we can access our services or anywhere. Let's say if they will be having the servers at global level, right? So you can access your services through your login at any point, any time. There will be security. So AWS itself provide us the security, and even in depth at service level or data level, we can further maintain the security and all. And coming to maintenance, you don't need to maintain anything in AWS except for few parts like internal things, like whenever you are creating data, I mean creating jobs or creating data, like that kind of maintenance. Except that kind of maintenance you don't need to maintain. If there are any updates, like you see, like for services or for applications in our laptops or systems or mobile phones, you will be getting updates, right? So you need to update it from Play Store or App Store. So that's what maintenance. They will be taking down that application for 10 seconds or 20 seconds for that download and installing, right? So coming to AWS, it will take care of from AWS server side. So whenever there is an update for any service, they will be doing from their side. We don't need to do. So whenever there is an off time, there will be 1 hour or 30 minutes downtime. Whenever we are not using, there will be some dark spot in the time as well. So that time they will consider that and they will update the service. So we don't need to do anything to update or manage or maintain anything. So AWS will be taking care of that. And coming to data management, so we discussed like that AWS will be managing the services. We will be maintaining the data. So for that, we'll be maintaining two architectures. We'll be having two architectures. One is traditional, and the other one is data lake architecture. Traditional architecture in the sense it's like maintaining the data in databases like tables, columnar format, and all. Data lake, modern data lake architecture is maintaining it in the file system. So you might get a question: what is the difference between traditional and data lake? If we are storing it in file system in data lake, how can we know what are all the columns we have, what are all the tables we have stored in that data lake? So for that, we have few concepts like Apache Iceberg and Apache Hudi. So they are nothing but a tables created on a file system. Let's take example of AWS S3 is a simple storage system in AWS which will be storing files in a folders and files, like the data will be stored in files. So let's say I have 10 tables stored in data lake, each table in one folder. I wanted to maintain that like a table in database. So for that, there is Hudi, which will be storing metadata. It's nothing but a configuration. Hudi is nothing but a configuration. So it will have some metadata like what is the table name, uh, when was the last committed, what are the primary keys in this folder, what is the schema of this folder, what are the data types of this column. That will store that metadata. There is nothing new in here. It just stores metadata in a separate file in that table folder. So it won't be a new thing other than database. It acts same like database tables, but here the database is files. I mean, the tables are nothing but folder. So any questions so far or any doubts?
No, Srikant, looks good. Thank you.
Okay. So AWS toolkit. So AWS toolkit is nothing but all the services that are available in AWS cloud service. So basically what we discussed earlier is ingestion, processing, transformations, right? So we are looking at few services that are useful for data ingestion. So let's say consider SQL Server my data source for now. I wanted to integrate that SQL Server data, I mean ingest that SQL Server data to AWS services like S3. So what we can do is we can use data migration service. These are all the services that AWS provides. Data migration service, Kinesis, MSK cluster, Airflow, transfer family, data sync, Snowflake. So all these are similar except for Snow family. Snow family is like a hardware. So if let's say if I have 4 TB of data, so or more than that, if I wanted to migrate the 4 TB of data from on-prem server to cloud service, it will be a little hectic. Like whenever I'm doing from a remote location, let's say I'm doing it in like a remote location, like in the edge of a forest where I don't get much of internet. So connecting to servers and all will be little bit difficult. So what Snow family will do is they will be having a snowball, which is a hardware like pen drive or hard disk. They will send it to our location. We need to copy that and send it back. They will that will be uploaded to cloud service. This is only the Snow family will be a physical drive. The other things are services only: DMS, Kinesis, MSK cluster, Airflow, transfer family, data set. All these are services only. So what DMS do is, so it is data migration service. So you all heard about data streaming, right?
Yeah.
So in general, if you are watching Netflix, so the movie files will be stored in servers, in chunks, and whenever you are accessing this Netflix UI, the data will be streaming from server to your application. So the streaming, the chunks or the data packets will be streamed, right? In the similar manner, the data migration service will migrate data from SQL Server to cloud service. So in SQL Server, you may have heard about CDC, change data capture, right?
Yeah.
So if you enable CDC, what it will do is it will create one more CDC table, and whatever the table you are creating CDC, it will create one CDC table for it. It will track the changes. So whenever there is an update happened for one particular record, that record will be inserted into CDC table, right? So DMS will be able to pull those updates and write those records. I mean, update those records from on-prem SQL Server to cloud service. You got it, right?
Yeah, Srikant. Yeah.
Yeah. So there are three types of migrations we can do using data migration service. So one is without enabling CDC, we can just replicate the table. However, the table is in SQL Server, we can replicate the exact table into cloud. And the second one is replicate and load incremental. So for that, we need to enable CDC. Once the CDC is enabled and DMS is started, we can just it will do the initial load, like the exact replica of that table to cloud service, and there from there on it will track the updates. Whatever the record updated, that update it will replicate into cloud service. And the third one is only the incremental data. Like, so you need to enable CDC, and it won't do any initial load. So it won't replicate the entire table data. It will only track the updates. Even Kinesis will do the same. And MSK cluster, it is a cluster managed for Kafka. So again, Kafka will be doing the same what Kinesis and DMS is doing, but we will be having a cluster specified for Kafka. We can configure the cluster, and we can launch the number of Kafka configuration, Kafka connectors in that, and it will load data. And app flow will be the same, and but transfer family, it is like copying files. For copying files, you all heard about SFTP servers, right? So they will be having some servers to copy files into that servers. You need to log in using SFTP protocol, secure file transfer protocol. So transfer family is such server. So you can do, I mean, you can create this SFTP tunnel to cloud service, and using that SFTP cloud service, you can copy files. I mean, I have a file in an on-prem server. I need to copy that file from on-prem server to cloud service. I can use transfer family. DMS will be migrating databases and tables. But coming to files, we need some service, right? So for files ingestion, like a text file or CSV file, Excel or JSON file, whatever it might be, we can use transfer family to automate. You can download it and upload it manually. Coming to bigger files, it will be hectic to do the manual stuff for uploading files to cloud service, right? So for that, we can use transfer family. And for processing, so till now, we discussed about few services which can be used for data ingestion. So where we can copy files or copy databases, tables, replicate the tables, track the updates and all. This is the ingestion part, loading the data from source to some point in cloud. It might be AWS SD or Redshift or some other storage service or Snowflake or something else. And also physical physical data movement using the Snow family, like ball and all. So now we need to process whatever the ingestion we did, data ingestion we did. It will be a raw data. So we need to do some processing or transformations. So for that, we have a couple of services like Lambda, Glue, EMR. So coming to Lambda, Lambda is nothing but a service which is provided to run your programming programs. Like let's say if you write a Python application, just a Python code, you wanted to run that, you can run it in Lambda. But Lambda will be having its own limitation. Like it can run for only maximum of 15 minutes, and it will be having a memory of up to 10 GB only. There will be a cap for that memory, and it will be like it will be for minimal jobs which will take only 1 2 minutes or 5 minutes, and it won't take 500 MB or 1 GB of memory. So it can support many languages like Python, Java, something, I mean, Go, Ruby, whatever the language you can write and run those jobs in Lambda. But as I mentioned, it has its own limit. It can run for only 15 minutes. After 15 minutes, it will directly time out, and it won't run further. And you need to submit the job again. And the memory cap of 10 GB. So Lambda will not be the ideal solution for bigger jobs. It is for only the smaller jobs, like I said, like 5 minutes Python program or C sharp program, Ruby program. It's just minimal program. But coming to Glue is serverless. Earlier we discussed about EMR, right? So EMR cluster we can create on AWS servers, and we can run our Spark jobs. So for that, you need to create cluster on your own. You need to provide the configuration. You need to set the Spark, the job running commands and all. So that will, like, you need to pay that cluster. Let's say you created 100 GB of cluster. and you are using only 50 GB or 40 GB, but you are wasting that 60 GB, right? But still you need to pay for that entire 100 GB of cluster. So there will be a little bit, it will be a little bit costly than glue, and also it needs a little bit of maintenance from our side, like cluster running, stopping. If the cluster is running continuously, if the cluster is up and running, it will cost us. So we need to cut down that cost, right? So uh, for that you need to stop the cluster, and when you need to run a Spark job, again you need to run the cluster, which will take around 4 to 5 minutes, which will be a waiting time for our Spark job. That means our job will not start immediately. So to reduce that maintenance and all, AWS introduced Glue, which is a serverless. So serverless in the sense they will have their own servers, and we don't need to create any clusters, any uh, configurational up create cluster. We don't need to run it, or we don't need to stop it. All we need to do is we just need go directly to AWS Glue UI, create our job, and set the configuration. So let's say if I need only 20 GB of memory and 5 nodes, I can set that configuration and trigger it. It will directly start running that job, and it will, once the job is completed, it will end that, it will close that connection there. So from the start of execution till the end of execution, in between that time, whatever the resources we are using, for only those resources we will be paying. Unless, like for EMR cluster, once the cluster is up and running, till the end we need to pay for the entire resources we are using, we requested. But for Glue, we can auto scale up and down. We have that auto scaling up and down is, like we will be setting some limit. If my job is expecting more resources, I mean taking some time or reaching some threshold, it will request few more resources that are needed till the limit I set, and it will charge for that. So it's like start of the job till the end of the job, whatever the service resources we are using, we will be paying for that only. So these are the processing tools that we are going to use. And in recent, earlier it was EMR, where they will be creating clusters and running the jobs in there. But in recent times, let's say like from last 2 or 3 years, most of the organizations are using Glue because of its low maintenance and high availability, and all. They are using Glue most of the time, and even EMR is being used. But as the latest service, Glue will be having more flexibility for the developers. And pipeline orchestration in the sense, so we built this DMS. We built, let's say we built this glue job. Let's say I have 10 glue jobs. I need to run 5 glue jobs at a time, and after those 5 are completed, I need to run the remaining 5. What I did. So we need to maintain that orchestration, right? Either it can be scheduled, or it can be the flow of jobs execution. I need to run 5 jobs initially, and once those 5 are completed, I need to run the remaining 5 jobs. So for that orchestration, we have Glue workflows, step functions, and Apache Airflow. So Glue workflows, all these are similar. AWS Glue itself provides workflow option where we can directly create this glue job dependency in the workflows, and we can create one workflow, and inside that we can create these job dependencies. And now I have 20 jobs. Let's consider I have 20 jobs, 10 jobs of one set and 10 jobs of one set. So from this first 10 set of jobs, I need to run 5 jobs and then 5 jobs. These are one set, and then I have second set, which will be in workflow 2. It's again like 5 jobs, 5 jobs. So Glue workflows doesn't have flexibility to call one workflow from another workflow. Let's say workflow 1 is completed, but I wanted to trigger workflow 2 immediately after workflow 1 is completed. So glue job doesn't have that flexibility to run workflows one after the other. So in that scenario, step function comes into picture. So again, step function is like integrating other services as well. We can trigger glue jobs or glue workflows or Lambda functions or EMR. Because whatever we want, we can configure in step functions and it will run in parallel. I mean parallel or sequential, whatever the order we are expecting. And Apache Airflow is like open source. We can create the same work. I mean, whatever we are doing from the step functions, we can do the same using Apache Airflow. We can write some Python programs to orchestrate all these workflows, Lambda functions, or alerts. We can do anything, whatever we are doing inside AWS using step functions. We can do with Apache Airflow. So this is how these are the few services that we can use for orchestration, and we have the final thing like data utilization. So initially we ingested data from data sources, whether it can be Salesforce, SQL Server, or front-end applications or forms or somewhere. We are ingesting that data from source to cloud service, and then from in the cloud service, we are creating jobs for processing and also transformations. And once the jobs are created, we need to orchestrate all the jobs to run parallelly or sequentially or scheduled. For all the things, we are using orchestration. For orchestration, we are using step functions or glue workflows or Apache Airflow. And once the jobs are run successfully and the data is stored in a storage system or warehouse like Redshift, Snowflake, or S3 or some other database, we need to utilize that data, right? We need to generate reports or query that data. So we are storing data in AWS S3, which is a file system. I wanted to query the data stored in S3 file system. So in general, in most of the scenarios, if we consider our Windows machine file explorer, we can't query, right? We can store data in folders, files, but we cannot query. But AWS provide that uh, provision for us to query files in S3, which can be done from Athena. Athena is a service where we can just write SQL queries on top of AWS S3. So for that, to query files from S3 using Athena, we have a concept called data catalog. So data catalog is nothing but uh, it's nothing but like database. So which is like organizing data from files. So in data catalog, we can create tables using these S3 paths, and they will act as whatever the table we are creating in the data catalog. We can query that table using Athena. So whenever you are doing select star from some test table, the test table is pointing to some particular folder in S3. This query will be pointed to that S3, and this Athena engine will be querying, reading that entire S3 folder and returning the data for query we wrote. So we have a few things to discuss regarding the data catalog and how we can create the tables in data catalog from AWS S3. We will be discussing it in depth later, as this is a high level. So the next one is Redshift. Again, Redshift is a data warehouse where will be having databases, schemas, tables, and all. Even there we can query the data, write our queries and all. And again, we have Redshift Spectrum. So Redshift Spectrum is similar to Athena. So in Athena, we'll be creating tables in data catalog, and we are creating queries, right? So Redshift Spectrum is we will be creating external tables on top of S3. So in SQL Server, you all might have gone through external tables where we will be creating files on top of tables on top of files. It is also similar. So here we will be creating one external schema, and in that external schema we will be creating external tables. So each table will be pointing to one particular S3 folder. So whenever we are running queries, it will be reading the data from S3 files directly. So the difference between Redshift and Redshift Spectrum is, in Redshift the data will be stored in the database. In Redshift Spectrum, the data will be stored in a different location, like in S3. So you got the difference, right? QuickSight is another reporting tool which will be similar to Power BI and Tableau, which will utilize data from Redshift or Redshift Spectrum. So all these services, whatever the services we discussed, from data ingestion to data utilization, all these are pay as you use. So whatever the resources we are using, we will be going to pay for that. So all the services will cost us, and what are, let's say if I am using two nodes for a Redshift cluster, I will be going to pay for that two node only. So that's how they will be costing us for the services we are using. So any doubts so far for these AWS services, ingestion, processing, utilization, and orchestration? Any questions?
No, it looks good so far for the first introduction, I guess. For me, at least.
Uh, so others are also fine, right? Okay, I will take the tests then. So data security and governance. So far we discussed about what is data engineering, what is big data, and what is cloud service. What are all the services we are going to cover in AWS, and so these are all the part of data engineering, and the major part of all these we discussed is data security. So as data engineers, we need to make sure our data is, I mean, the customer data is not visible to others. Let's say if I'm working on a healthcare domain, so in US in general, it's illegal to share healthcare data, one person's healthcare data to others. So there will be some security concerns, right? So even if you consider in India, revealing the other data is not, I mean, revealing the other data from other person without the consent of the actual customer is illegal, right? So we need to maintain that level of security to reach that expectation. We need to maintain few security measures, which can be encryption, access control, data masking, and monitoring. So encryption is we are migrating data from cloud service to AWS clouds. I mean, on-prem server to cloud service, right? So the data will be transferred over the network. So the server will be at one place, cloud service will be at one place. We are moving the data from one place to another place through different networks. So while transferring the data, there might be a possibility there will be a network breach, and they will be reading or accessing our data from outside the network. So for that, we need to do the encryption. It can be network encryption or data encryption. We can do both the things. First one is network encryption. I mean, we have some concepts in VPC, bringing both the services, both the servers, like on-prem server or the cloud server, into same network, and then do the transfer, data transfer, and data encryption, which will be little bit costly to do use data encryption. So that's where network encryption will take place. And the second one is access control. So let's say uh, in an organization there are 100 employees working in data projects. So all are using same same AWS account, but only for each project there are 10 members. uh, One project member should not see other projects data. So for that, we need to maintain access control. So in AWS, we have some concepts called IAMs and few rules. We can set rules. So let's say if all the projects, all the 10 projects data is being stored in S3, same S3 bucket, I mean same S3 storage in different buckets. I don't want other users, other project members to see my project data. So for that, I can set some policies to my S3 bucket, which will make them not which will make the data not accessible to other users. So it's like I'm just explaining it in a file system level. We can do it in data warehousing part as well. We can create some roles. We can assign some create some roles and assign some policies to it, and we can, while firing in the table, we can hide the data in there as well. And data masking in the sense, as we all know that in recent times we have masked others, where our other number will be hidden with stars. That's nothing but data masking. So we can do that data masking for phone numbers, email IDs, or some confidential data and all. So and these are all the things we can do to encrypt or control access or hide data. And to do, once all these steps are taken care, we need to do one more thing: monitoring. So monitoring is nothing but just regular checks that we are doing to see whether data is encrypted or data is visible, or whether the different role person is accessing the other person's data or not. All these things we need to do frequent monitoring. So this is also comes under data security, as we are monitoring all these steps. And going forward, we'll be having a few more things that we can see, like we have AWS. AWS provides a few services which will provide the data security, like KMS, Guard Duty, and some other services are there. We can discuss them later. And the next step is data swamper care. So as we are discussing about big data, so the data will be very much used, right? So let's say if I am having 100 TB of data, so having that 100 TB of data at one place will get confusion for users. So what is this data? How is data being used? Where? How can we use it? What is this data? I mean, what kind of data is this? A lot of questions will rise. So for that, we just need to create the metadata or data catalog. So what kind of data is this, and how we can utilize it? It's like a documentation part. You can consider it like a documentation part. So once the data catalog, I mean, we need to avoid the confusion that we get when we see the data. So obviously, if we are seeing less amount of data, it will be pretty much straightforward and clear. So suddenly, if we are seeing a huge data, if I go into some place and just suddenly saw 1 TB of data first time, and I don't know what to do and what is the data about, and all these things, right? So I need to understand data. So to understand data, I need some inputs. So like there will be few basic questions: what kind of data is this, for which organization this data belongs, for which domain this data belongs. So what is this acronyms means, like there will be some short forms, what are those mean. If it is a healthcare domain data, so there will be classifications like claim insurance data, patient details, and diagnostic details, prescription details, medicinal details. All these classifications we need to do, and the ownership. So if I got some doubts in diagnostic details, whom should I contact? That ownership. A person should be having the ownership of data he is dealing with, and the data quality. So for all these data, if I see, if I'm doing some calculation over some cost and all, at one point I'm getting for my calculation at for one patient, I am getting some value which is matching in the database. And for some other patient, it is not matching. So that means the data is not appropriate. So the quality is missing. So we need to maintain that data quality. And security. Security is again the same things we discussed. Like we don't need to reveal, we should not reveal patient's information like phone number, email ID, some other details. We should not reveal them, and we should not. Everyone should not access all the details. All these things we need to maintain. And user training. If a new person, a new data engineer is coming to look at our data before directly looking at it, we should give some training to avoid the confusions, right? So we need to give the basic details at least. And we are going to discuss about one AWS service, which is AWS Glue, which we already discussed a few things, and a little bit we are going to discuss a little bit about it. Uh, so AWS Glue again, it's an ETL service which is a serverless as we discussed, which means we don't need to create a cluster, or we don't need to create a server or cluster or anything. We just need to create our own job, and we can just configure the amount of memory, number of nodes we needed. We just need to configure that and just trigger it. It will run and it will cost us what are all the resources we are using. So there will be AWS Glue provides one more provision for us, which is visual ETL. In general, if you are building a Spark application or big data application in a traditional way, you need to write it on your own completely from the start of the application to end of the application. You need to write on your own, but AWS Glue provides visual ETL. So which means there will be having some sources, targets, transformations, and all. Everything will be there in the block. You just need to drag and drop to the canvas, and just uh, read the tables, do the transformations you need, and write it back to some file system, which will be very much easier than writing a traditional Spark application. So data catalog. So what a data catalog? So earlier when we are discussing about Athena, we came across this data catalog. Data catalog, for one AWS account, you will get one data catalog, which is similar to a database where we'll be having the tables, schemas, and tables. So inside this data catalog, we can create tables on top of S3 folders. So I have three S3 folders which I wanted to have tables in Athena. Athena will be querying in this data catalog. I mean, data catalog is a database. We will be creating tables in that data catalog on top of S3 folders, and Athena will be querying these catalog tables. So how we can create this catalog tables? For that, we have data crawlers. So what data crawlers will do is, if I create a data crawler on a particular folder, it will crawl that S3 bucket or S3 folder, whatever the location I give. It will crawl that folder. Let's say I wanted to create one table from a S3 bucket, and I am creating a crawler and pointing that crawler to that S3 location, whatever the S3 location I wanted to create table. Once we create that crawler and we run that crawler, it will crawl files from that folder, and it will evaluate the schema. It will read first 1,000 lines of each file, or there will be some limit like 500 or 1,000. It will read that much records from each file. It will evaluate schema, generate schema, and create table name with same as that folder name in that data catalog. You got that point, right? I'll take that as yes. So once the data catalog tables in data catalog are created, there might be a scenario where the files are having different schema. Let's say today in one folder, when I'm ingesting data, I might be having 10 columns, and after 1 month, uh, the ingested data is having one more column, 11 columns. So I wanted to reflect that schema in the catalog tables as well. So when I run that crawler the second time, what it will do is it will create a second version of that table with 11 columns. So it won't create a new table, but it will create a version 2 in the for that table. So version 1 will be having 10 columns, and version 2 will be having 11 columns, but it will have the entire data of that folder. So the schema evaluation, it will whether it will be having less number of columns or it will be getting more columns in future, it will handle in the catalog from the crawler side, so there won't be any issues with schema compatibility. And we will have this get data catalog, data crawler separately, as well as glue job inside glue job itself. So we'll be having, when we are running this ETL job, we'll be having a provision to run the crawler when we write data to S3 folder itself. So inside that job also we can run those crawlers. So lake formation is nothing but creating storing the data in files like S3. So whatever the data we are ingesting, processing, transforming, we might need to store it somewhere, right? So as we discussed, we will be storing it in AWS S3, so which is nothing but our data lake. And as we discussed earlier, we have some encryption services provided from AWS side, which is KMS, MACI, and Guard Duty. KMS is nothing but a key generated. We will be generating a key and using that as encryption key for folders. And MACI use machine learning. MACI use machine learning to hide, mask data, and it will do like data masking, access control, and all. And guard duty will be like whenever a security breach happens, whenever an unauthorized access comes into picture. So these kind of things it will monitor and alert us. So I think these are all the high level topics that we are going to discuss in depth in future. So we discussed about data engineering, big data, how data is growing, what are all the cloud services, and a few services of AWS, and the pipelines, what are all the services we can use for data pipelines, what are all the security measures we can take, what are all the security that AWS is providing, and few things like what data engineer do, data scientist do, data analytics do. These are all the high level. We discussed only on a high level note. So far, any questions or any doubts, anything else you wanted to discuss?
Hey, Srikant, thank you so much for the session. It is really wonderful. So I just want to know a basic question. I think it feels so naive, but yeah. So how much of AWS knowledge do we require to start this?
So to start building data pipelines.
Yeah. So to I mean, in other word, I would say to get along with this course.
So you just need to know what AWS is,
Okay.
how we can use AWS. So coming to services, what each service will be doing and all that we can discuss. But what we discussed in the first slides, like a cloud service, what is a cloud service? How helpful a cloud service is when it comes to big data. So these basic things we need to know before going in depth into each service. So there will be concepts like we discussed, like streaming, batch cycle, and a little bit about Spark, and yeah, the configurations. What is nodes? What are master nodes, worker nodes? These are basic technologies that we just need to understand, and even we are going to discuss them again in EMR concepts. So if you know that previously, that will be very much helpful for you to understand more. I mean, you will understand AWS service much faster if you know them previously.
Yes, Sridham. As part of these sessions, do you have any hands-on projects which will be covered as part of these sessions?
As of now, I don't have any projects ready, but I'm doing few things for hands-on. I will share them once we get to that part.
Okay.
Yeah, as each and every service in AWS is costing us, we need to monitor that, and we need to make sure we are using very much minimal cost. So I'm just exploring the minimal cost things, and we'll get that hands-on.
And do you
Any other
think do we need any AWS certifications? It need to be, it can be taken as part of. I know this is generally data engineering part, but still, do we need to take any certifications? And
So once this course is done, you should be able to write. You should be able to complete certification. I mean,
okay.
in general, AWS certification mostly deal with real-time scenarios. I mean, the questions in there will be real-time, most of the question. So once you get to know all the services, how the data transfer happens over this network, so how we are configuring VPCs, private networks, and how we are building these pipelines. Once you get to know all of this, it will be easier for you to go for the certification.
And do you prefer any specific certifications as part of data engineering? Do you,
So the basic certification there will be a associate. I didn't remember the exact name. Associate solutions something. That will be
solution?
the basic. We can go for.
Okay.
Any other questions?
How many months it would be take up for to become a Azure data engineer?
Sorry.
How many months it would be take to become a this is a data engineer, no? Azure data.
So it depends how fast we are going. So if we are fast enough, we can do it in like 2 months. Or if we want to take time, if you want to go slow and go in deep for each and everything in AWS, it might take some more time. Yeah, it depends on individual. We can't assure how much time will it take for to become a data engineer. But in an ideal situation, it will be like 2 to 3 months, not more than that.
Any programming is required for OOPS concept like full programming language is required. Any program language.
So any programming language, I would suggest to go for Python. Not it's not traditional Python, but Python with Spark, PySpark. It is for only it is for only Lambda, Glue, and EMR. So other things, it's like they will be having like UI options. Check the option and configure it. But coming to this Glue, EMR, and Lambda, we have to know some programming. I would suggest to go for Python. We can go for Scala and as well, but Python will be ideal for data.
And for data extraction parts, we are using only Glue, or is there any other tools?
For data,
Extraction and transformation.
so for processing and transformation, we are using Glue and we have EMR, and also we can use Redshift for processing and transformation as well. But it varies from project to project. Like some might use Redshift, some might use EMR, some might use Glue. But every service will have its pros and cons. Depending on the cons, they will opt for other service. So let's say if I'm going for Redshift, I if I'm going for Redshift, I need to create a cluster for data warehousing, processing, and all. Let's say if I have 4 node Redshift cluster, all my jobs run on that 4 node cluster, and I need to pay for that 24/7. But coming to Glue, I can scale up and down the number of nodes I needed. So it's like flexible, and I will pay for that particular runtime. Unlike Redshift, I can pay for only that much time. So we can go for Redshift, we can go for Blue, we can go for EM. And for very minimal Python program, to have a Python program, I can run it in Lambda as well. And Lambda will be having some free tier up to some limit, like some number of run per year or account. There is some free time.
And also, as part of this session, do you have any session on data modeling?
Yeah, we can plan for that at one point. I think we need huge data to do the data modeling, but basic data modeling we can cover. With minimal data, we can cover the data modeling part.
Hi, Shrikant.
Yeah,
Is it audible?
yeah.
Okay. So in ETL tools, I mean, we use some programming language for the custom transformations, right?
Yes.
So in AWS Glue, which programming languages are allowed except for Python
Scala is allowed.
and Java?
I think Java. I think it's not allowed. Only PySpark and Spark Scala.
Okay. And during this course, I'm sorry, I'm sorry.
Yeah. Go ahead.
And during this course, are we gonna also cover Redshift completely?
Yes.
Okay, so Redshift is a data warehousing basically, yeah?
Yes, we are considering it as data warehouse and we will doing it.
Okay. Thank you.
Any other questions?
Yeah. Also, I mean, I forgot to ask. There have been a lot of data migration projects lately from on-prem to cloud.
Yes.
Is it possible for you to cover one of the data migration projects for us to understand how exactly does it work in real time?
Yeah, we can cover it, but to get that hands-on, it might be a little bit costly. I mean, we can do that in a traditional way. Uh, yeah, we can do that. We'll cover one of the project using either DMS or Kafka, and for processing, we can use Glue or Redshift, and for data
Perfect.
lake, we can use S3, and warehouse we can use Redshift. We can cover that.
Perfect. I mean, if you also cover in the traditional way, that would be better, and you can give us the high level idea how exactly does it work in real time also. So yeah, thanks.
Yeah, sure.
Thank you.